In this programme, we're exploring ways in which ICT can help with those more challenging aspects of primary maths.
In the first part of the programme, we look at how one teacher introduces decimals using the interactive whiteboard. In the second half, we'll see how interactive software can help students tackle the abstract concept of rotational symmetry. But first, decimals.
Children often struggle with the smallness of tenths and hundredths, being asked too quickly to compare decimals and calculate, without having a true understanding of their real value. If I take this chocolate bar, for example, and break it into 10 equal pieces, each one's a tenth. And if I break it into 100 equal pieces, each one's a hundredth. Easy as an adult.
Let's see how Paul Greenwood uses ICT to develop a mental image of this with his Year 4s.
Joshua, what's the smallest number you can think of?
1.
Okay, number 1. So what have I got here?
It's chocolate.
Okay, and if you had to think of a number, what number would go with this?
1.
1. Okay. Now, Joshua,
Of course, the 1 changes when he eats a bit.
that's now smaller, isn't it? So we have to have a number smaller than 1. And that's what we're working on today. We want you to understand the value of a tenth and a hundredth.
To begin the lesson, Paul displays a square representing 1 unit using the interactive whiteboard to illustrate the relationship between a whole, tenths and hundredths.
We've now split up our 1. We split it up into 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 parts. Okay. Can anyone tell me what we would call this part here?
1/10.
So you're calling it 1/10, so you're using your fraction knowledge. Okay.
The pupils are familiar with fractions. They've recapped tenths and units, and before they move on, Paul reminds them of hundredths. He uses presentation slides on the whiteboard to clearly show this further division of the whole.
But what have we done now? We've actually changed it now. Before it was split into tenths. Can anyone work out what we've now split that one whole into?
It should be 100.
Fantastic, Temi. We've now split it into 100 parts, and each part is worth a hundredth. This game is called...
Paul wants the pupils to understand the connection between fractions and decimals. To do this, he's going to get them to play a free online game.
OK, let's play.
First, Paul plays against a pupil on the interactive whiteboard to demonstrate the game to the whole class. The player starts their clock and a fraction is represented by the shaded hundredth of the whole square. The player has to work out the fraction and enter it as a decimal in the box below. They stop their clock and then it's the next player's turn.
So it's 95 100ths, so that's 0.95. I stop my clock. You'll go, Amy.
0.3.
Well done, stop your clock. You're well in the lead.
The pupils then play in pairs on laptops. Shared learning in this way helps develop their grasp of decimals.
Let's play. Beginner, advanced.
No.
You start first.
Me. It's me.
The time's going, haha. 1, 2, 3, 4, 5, 6, 7, 75.
The pupils struggling with decimals play together on the interactive whiteboard. The teaching assistant guides them through the game, and with the clock ticking and their friends competing, they really focus on the task in hand.
0.4.
Right, stop the clock.
Stop.
9.2. Well done. Stop the clock.
0.8.
I feel the ICT in the lesson particularly benefited the children who are working with Karen. The idea of playing a game, they had so much enjoyment out of it, and I'm not sure if they realised how much numeracy they're actually learning from today.
With the game having shown the link between fractions and writing decimals, Paul then returns to fractions to introduce a new unit. By using animation on the interactive whiteboard, he can show just how small a thousandth is in comparison to a whole.
What we're going to look at is a thousandth. So we've got one whole, and you're going to see a thousandth of that shape. So here's our squares getting smaller and smaller to see how small 1,000th is. And now if we compare that, now how many times does that square fit into this big square?
1,000.
Okay, now if we return to our piece of chocolate, now if I said to you, you can have a whole bar or 1,000th of a piece of chocolate, I think you'd be disappointed with 1,000th. So just imagine how small 1,000th is.
To round up the lesson, Paul tests the pupils' translation of fractions into decimals using a multiple choice quiz on the interactive whiteboard.
Which number is equal to 2/10?
2.
So it'd be 0.2. Good boy.
And I'm looking round, and well done. I can see a lot of people who've done 2/10 as a decimal. So well done. There's some fantastic work on decimals and fractions today. Now, what I want you to do is have a look at home and see where you find decimals and fractions, and you can tell me tomorrow where you spotted some. But for today, that's the end of our decimals and fractions. Thank you.
So, has the visual nature of ICT helped these pupils with their understanding of decimals?
I think it's easier to look at pictures with topics like this.
I think using computers in maths is fun.
It shows you the things and then you can pick it up quick and do it. Beat the clock helps you with that with decimals.
I felt fantastic as a teacher to see that they'd moved on with their knowledge and really enjoyed the activities that they used for that.
Now, let's take a look at another challenging topic. On the surface, symmetry might seem an easy concept to grasp. However, many children lack the visualisation skills in order to spot reflections and rotational order. Now, this wheel has rotational symmetry, as you can make a replica image by rotating through less than 360 degrees. And this has a rotational order of 7, but it's not so obvious in a plane shape like this. Friedel Gotzer explores this with a group of Year 6s identified as struggling with rotational symmetry. To begin the lesson, Friedel is going to be illustrating the abstract notion of rotational symmetry by physically rotating eye-catching images of Japanese family crests on the interactive whiteboard.
What is the rotational order of this Japanese crest? Jessica?
2.
Right, it's going to have a rotational order of 2. Anyone who's got a different guess?
I think it's 3.
Right, now let's have a go and see if you are right. Okay, I'm rotating it. You can count every time you see it's got a rotational order.
1, 2, 3.
Well done, Christopher. You were right with your rotational order of 3. Jessica, can you see where you've got your bit wrong? Excellent, that's good. If they can actually see, this is what happens when you rotate the shape, and all of a sudden the penny will drop and they will realise that's what we're on about. Let's have a look at the first one there. Do you think that this pattern will have rotational order?
I think it's going to have 3.
Now let's have a look and see if you are right.
1, 2, 3.
Excellent. It's got a rotational order of 3. Well done.
Next, the pupils are going to design their own images.
What you're going to do, you're going to create your own family crest, okay, using a rotational order of 3.
Using symmetry software on the computers, the pupils specify a rotational order of 3, and the program then visually creates this image from their own designs.
Some interesting shapes that's starting to appear. And as you are doing it, think about the rotational order. Can you see how the rotational order works? If you want to create a more complex pattern or shape, you can use circular lines like that.
I've tried to make these red lines and the blue lines and the purple lines make a rotational order of 3 on the computer.
So, what do the pupils think of using ICT to learn about rotational symmetry?
It's really good. I wish we could do it more. I find it easier to remember it in pictures. because you can actually make stuff with it and you can actually learn from it.
It's more interesting to use a computer than to write it in your book.
You get to create your own Japanese crest sort of thing, and it's better than drawing a new one.
It's far easier for them to actually use something that's visual, where they just have to click on the mouse and they can create that image and they can see how it rotates.
With a range of crests now on their computer screens, the pupils take a look at each other's designs.
You see, it's going to be like a maths gallery where you go and view someone else's artwork. Have a look at the rotational order. See if you can actually pinpoint what the rotational order is of that pattern.
The complexity of some of the designs prompts discussion.
Well, I think, if you see the blue lines, they're all going to have a rotation order, and the red ones, and the purple one, and the black one. But the blue ones won't, because you've got this bit here, because it's going to have a rotation order of 2. The blue lines, these blue lines, but not this one because it's different.
I think it's right.
Yeah, right, but just about that bit.
That bit is right, because if you rotate it there, it'll look the same as that. And that one will go there. And if you rotate that one, it'll go the same as that.
It's really hard to tell if it's like got rotational symmetry or not, and it's pretty hard. But the outside lines and everything are pretty easy.
There is 3 lines of rotation in there, because if you see the black ones, they're all the same, and there's 3 black ones, there's not more than 3.
Some of the pupils discuss whether these designs also have mirror symmetry, and if so, whether the images are correct.
I think it isn't equal, because if you look at the mirror and you see that, it isn't equal. We have an argument and say, which one is the correct one? Is it the symmetry or the rotation?
Rotation.
I have to say there was some really good discussion going on, especially in the end, where Christopher was pointing about the mirror line, the line of symmetry. Now, we are not actually discussing the line of symmetry or reflective symmetry, but we are discussing rotational symmetry, okay? But well done, you did point that out very clearly.
To finish off the lesson, Friedel goes back to the interactive whiteboard to look at some more complex shapes.
What do you think is the rotational order of this snowflake pattern?
I think it's got 6.
Craig?
I reckon it's 7.
I would have to look very carefully. Count when you see rotation order.
1, 2.
Using the ICT and maths makes a huge impact on the children. They really enjoy using computers to start with. Secondly, as a teacher, it makes your life a lot easier. It's a really, really brilliant source.
The visual nature of ICT can help us develop those all-important mental images, which in turn help make sense of primary mathematics. Remember, if you'd like more information about anything you've seen on today's programme, then log on to the Teachers TV website. Goodbye.